Hi guys, this is homework help for the refraction and reflection homework. If we are starting with refraction, we want to remember this equation here that we looked at in the notes, where n equals the index of refraction, c is the speed of light in a vacuum, which is 3 times 10 to the 8th, and v is the speed of light in some other medium. So looking at letter A, water has an index of refraction of 1.33, so that's going to be our n. We want to determine the speed that light travels in water. So we know that c is 3 times 10 to the 8th. And then we are looking for the speed of light in the water. So our formula is n equals c over v. We're going to do 1.33 equals 3 times 10 to the 8th over an unknown v. Remember, when you're looking for the bottom, you can switch places with the answer. So v will equal 3 times 10 to the 8th divided by 1.33. And that will get you the answer of 2.3 times 10 to the 8th meters per second. One thing to know when you're doing these problems, if you're trying to check yourself, is the v should always be less than 3 times 10 to the 8th. If you're getting a number that's larger than that, then something has gone awry with your calculation. Moving down to letter C, we have a laser that's going to go from air into water. So looking at our picture here, this line represents the barrier between the air and the water. And then you have the normal lines. Remember, the normal, it's just a line that's perpendicular to the surface. So it's an imaginary line, but it's where we're going to measure our angles from. To tell you, the incident angle, or the original angle, was 30 degrees, and that's always between the ray and the normal. And then the refracted ray, or the bent ray, was 23 degrees. So our laser bent here because it changed speed. It refracted when it went from air up here into the water. To figure out the answer to this, go back and look at the notes and think, if the ray bends towards the normal line, what does that mean about the speed? Moving on, if we look at the reflection section and kind of skip down to letter B, the question asks you to draw normal lines, incident rays, and reflected rays. So again, remember, a normal line is an imaginary line. It is perpendicular to the surface. So each of these lines here represent surfaces. So normal lines are just going to be imaginary lines that are perpendicular to the surface. Okay, and then your incident ray is your original ray of light. Okay, so let's say it comes in at this angle. Well, according to the law of reflection, it has to bounce off at the same angle. And so we're going to approximate, bounce it off here, and this angle should equal this angle. We call this one the angle of incidence because it's between the incident ray, or the purple line, and the normal line. We call this one the reflected angle because it's between the reflected ray, or the green line, and the normal line. The last one I want to look at is letter G, and I want to focus on C here under G. So you can go back and look in the notes and review yourself on what diffuse reflections are and what specular reflections are. You can look at the website that's linked to this page. It's got a great explanation. Something to remember is that if you can see it, then it is reflecting light. Your eyeball only works if light is being reflected into it. So when you look at your brother's face, his face is reflecting light into your eyeball, and that's why you can see his face. You cannot see your own face in his cheek, though, because he has a diffuse reflection. The light rays are not lining up in such a way that there's an image of you in his face. But you can see him, so it is a reflection, but it is a diffuse reflection. The difference would be if you look in the mirror, or maybe you look in the lens of his glasses, you might see your own face. That's a specular reflection because it's a smooth, shiny surface. The light rays are lining up in such a way that you actually get an image of yourself. But that's totally different than the diffuse reflection. The similarity is that both cases, light is reflecting off a surface into your eyeball. So when you look at letter G and you see on the third part of it, light from the overhead light strikes your body and reflects towards all your classmates' eyes. Well, they can see you, right? So you are reflecting light. However, they don't see themselves in your shirt. And so that means that you are providing a diffuse reflection and not a specular reflection. Same idea as letter H. If you keep looking down, when you look at this paper, you can see it. So it is reflecting light. You don't see your own face in it, though, because it's not a specular reflection. The light rays are bouncing off at all kinds of crazy angles. They don't line up in a way that you can see an image of your own face. I hope that helps. As always, reach out if you've got questions.